Um, this is an interesting image. This shows several things going on here. It shows saccades, which are green. It shows um, when you think you're fixating, uh, in but you're drifting. That's in yellow. And then there's micro-saccades, which are red. It's, it's confusing. The point of this is that your eyes are moving all the time. And I had a recent, even when you think they're fixed, like, so you think your fixation is in yellow here, and you can see the eyes are drifting during that fixation. And then there's this, there's this, a microsaccade. I'm not sure if that's the same as drift or jitter. There's just sort of, they talk about this
No,
jitter.
I think those are different. Yeah.
Yeah.
The drift is
Um,
more smooth and
no, right.
less
Drift is a little,
controlled.
but then there's a jitter and a microsaccade. So I'm not sure. They don't show the jittering here.
Yeah, I think the jitter is like even smaller than the
Right.
microsaccades. And
Right.
and that's like, yeah.
What Bruno Olshausen just told me recently, I saw him a few weeks ago. He um he told me that even during the smallest of these movements, that the retinal ganglion cells that are getting activated are completely changing. That is, there's no stability in the signal from the retina, um, which is surprising. He also pointed out um, that we're able to determine detail which cannot be captured by the resolution of the retinal ganglion cells. So, so the brain is relying on sort of integrating the retina is relying on integrating input. Excuse me, of the cones. I mean the photoreceptors, and so the retina is already doing some sort of time integration of information. Um, so I don't have any conclusion of this, but it's just something to keep in mind that when we think the sensor is fixed, it really isn't. And it's moving and things are changing all the time. And these changes lead to changes in the retinal output, and the cortical input. So, I don't, I'm not making any assessment of this. I'm just pointing out that when we try to think about the problem of, oh, you have a non-moving sensor, at least it comes with vision. It doesn't really exist. And it's constantly changing all the time. And that can impact the way I think about the problem a bit. Um, but I just thought pass that on because it's not obvious that stuff is happening all the time. It wasn't obvious to me.
Yeah. The
So
drift is
Oh,
much bigger
do you
than I
know?
would have expected.
yeah, I thought so too. Maybe I thought that, and I thought sometimes the cards are much larger. So maybe, but this says here, if you look on the bottom right of this image, it shows a little arrow. It says 1 degree of viewing angle. So this picture is
I
not.
wonder how long they were viewing it for, because just from a quick Google, it sounds like you might have like half a degree of drift per second or something. So you have to be staring at a point for quite a few seconds to drift that far.
Yeah, well, I don't know. That's a good question. I actually didn't read this paper, but let's not make any grand assumptions about it. All I'm just saying is that there's a lot of motion going on, and
Right.
even the jitter and these microsaccades are sufficient to change the output of the retina. And of course, it depends on how quickly these things change. I didn't find anything which said, the eye movements. Well, I don't know. I didn't do research on it. It wasn't the most important part of the work I was doing, but I just was curious about it because in the end, what I concluded, well, not conclude, I didn't conclude anything during studying this problem. What I came to realize is that um, there's no easy. I couldn't see an easy solution to this problem, and maybe somebody else does. But let me just walk you through my thinking about it, if that's okay.
I guess a quick,
Yeah.
like, not about if anybody has seen like a trajectory when the eye is doing pursuit movement, like how much kind of jitter, or like not the eye movement jitter, but how much variation there is if we're intentionally doing smooth pursuit. Like, is it um less sporadic?
Well, first of all, I don't know that answer. It's a good question. I do know I would be careful of the word intentional because you cannot intentionally do smooth pursuit.
Okay.
That it is it's sort of a reflex type of thing, and you can't consciously make your eyes do smooth movements. But the eyes will do smooth movements to follow a moving object.
Okay.
That's my understanding. But it's still an interesting question as to how accurate they are. You know, I don't know.
Yeah, maybe I don't know either. I guess the only thing is, I think it's thought that the micro-saccades are intentional, whereas jitter is potentially just like neural / muscular noise.
Well, when you say
So,
that, I thought the saccades were intentional, but not the micro-saccade.
okay, well, maybe it's in the open question, but I think there's at least a fair number of people who think micro-saccades have various purposes related to things like attention and.
Oh, they may not be. They may have purposes, but you're not aware that you're doing it.
Oh, yeah. Sorry. Right. Yeah. Sorry. Intentional as in intentional sort of from an evolutionary point of view, whereas
Right.
jitter, I think, is just like, that's sort of the resolution of that biology can do.
Right.
So basically I imagine with with smooth pursuit, you'd still have jitter and maybe drift, but maybe you don't have micro-saccades given the nature of it. I don't know. But,
And I think the question about drift was, is that are you just correcting an error, or are they functional as well? I think I've heard arguments both cases. Anyway, I don't want to spend too much time on that one. So I'm just going to go through some text here, if you don't mind, and we can talk about it. So first of all, and this is a summary of lots of notes of confusion I had. So this is like boiling it down. So what is the problem? The problem is we can recognize objects are briefly flashed on the screen. In theory, without sensor movement, but that's questionable if there's any sensor movement at all. But without sensor movement, our learning module voting acts like a bag of features. And therefore, presumably, Monty, with no movement, can't do flash inference. If we allow even the small amount of movement, we're no longer a bag of features. And so it's not like, Monty's useless. In fact, in the frameworks paper, we showed how just a few movements can really make a big difference in voting. Anyway, but if we assume no movements, and then it's like a bag of features, and then you presumably couldn't do any of the things that you guys are just doing. So therefore, the relative poses of sense features must be used during flash inference. That's a logical conclusion, I think. My logic is wrong. And this ability is missing in Monty. It's not clear how important this is.
Just to clarify, so Monty does have that ability, but we just don't know how it might be done in the brain.
Oh, I didn't know that.
Yeah, so Monty has the ability because what we give as input to learning modules are locations in the common reference frame. So we can easily use those to have the relative poses between voting learning modules. But the question is kind of, if we wanted to change that to giving only movement vectors, only displacements as input, instead of absolute locations, then...
Well, how does that work? All right, so then a lot of my analysis, I'm thinking about the neuroscience here. I wasn't even aware of this. I'm sorry about this. How do you solve the problem that there's n modules, and therefore who updates who? What? I mean, how do you? I really struggle with this issue. Is to okay, even if I know the location of each learning module and relative to each other, how do you update the learning modules to? How do they take advantage of that? Again, I'm thinking all neuroscience, so maybe I'm completely off base here. Can you explain that to me?
Maybe, Niels, it's worth pulling up the picture from the paper where we visualize that. So basically, we calculate the relative displacement between the sensory input that goes into the two learning modules that are voting. And then the sending learning module basically says, I'm here. I think I'm here. So given our relative displacement, you should be here. And then...
But if you have 100 learning modules, how do you do that?
Well, I guess
it does computationally, it does get expensive as you scale more learning modules in its current form.
Yeah.
But basically, you can imagine each learning module that's receiving votes. Let's say this learning module is receiving votes. It would do a different offset. There would be a different displacement for each set of votes coming in, depending on which learning module it was coming from, which
Well,
column.
you have to go, each learning module has to go through each other learning module one at a time.
I mean, you could do it in parallel, but they're done separately.
So it's an n squared problem then, right?
Yeah.
I mean,
Yeah.
in Monty, you can specify like a connectivity matrix of which learning module can vote with what other learning module. So you can make that sparser, or you could think of it in the future being like an intentional thing or whatever. But yeah.
And also here we send a lot of votes right now because whatever, but like you can make votes much sparser. You can imagine sending just, I don't know, 3 or 4 really important votes per learning module.
So my whole analysis might be off base here, because I was thinking like, okay, I'm working with vertical columns and what the representations have, and how would they do this problem? And I don't think they can do the way you've shown it here, because this requires a serial processing going through a list of other columns. And
I don't know if it's necessarily the serial nature, because it can be done in parallel. I think the issue is more
you can't
somehow
do
you
it
need
parallel.
to do this center displacement. Well, I guess it depends on how you're accounting for it. If you accounted for it before it came into the column, then you could do it in parallel. But that's the issue. Like with the lateral connectivity, it seems to go straight to like the layer that's meant to be.
But explain this to me, because I'm confused about this. If I'm one of 100 columns, and therefore there's 99 other columns out there, how would I process in parallel to accommodate all of their relative position?
Basically, all of the 100 columns would send out, I'm here and I have these hypotheses about where I am on the object. And then all the receiving columns would take that kind of I'm here signal and calculate the difference to where the receiving column is, and that's the displacement.
But you have to do that by column basis, right?
You can do it all at the same time. Like you can update all of them in parallel, because it's basically they just all send their hypotheses out, and they might send their hypotheses to all of the other learning modules.
Yeah, but I'm one learning module.
The other learning
I'm one learning module. I can receive all these hypotheses.
Yeah.
Right. But how would I'm trying to understand how the neural system would.
I mean, I think at least computationally, it's definitely can be broken down as a parallel computation in terms of like what neurons would do. I feel like an alternative would be more where, like, as long as each column was voting on more of like a central location, this would require basically that like different learning modules that know about different objects have a similar sense of like sort of this not necessarily the center, but like if I'm let's say I'm a learning module that knows about phones and I'm communicating to the next level. Okay, this is where the phone is in space. If there's some sort of agreement between the other columns that are sort of laterally connected about where this phone is in space and how to describe that, then they could vote directly on that. So as in, if they're all saying, oh, the phone is at this coordinate, which kind of localizes to this thing, then they're all going to agree if they're kind of seeing the same thing. And then the displacement kind of happens, that calculation happens once within each learning module, because they're basically taking their kind of object-centric sense of, like, rather than voting on where they are on the object, they're saying, where's the object in the environment in some egocentric coordinates. So they do that calculation internally, and then they project that.
I'm still confused by this, because no one, we don't know what the object is yet. Nobody even has a reasonable hypothesis.
Yeah, this would be a hypothesis, but like based on that hypothesis, they could calculate a location of the object.
But imagine in a real world, it's very unlikely a single sensation. It's very unlikely any column would have any reasonable hypothesis of the object. And so I have to assume that all I know is a feature, and the system might know, okay, someone might know in our current implementation, a learning module or a column, at least in our current implementation, wouldn't know where it is in egocentric space, but we can imagine somebody does. then I just still don't understand how I could say, okay, we have a whole bunch of people at different points in space relative to the body, let's say, and these different features. But I don't know what the shape of this object is. I don't know what the object is. And how would another way I looked at it was the following. I said, imagine I'm a column. Again, I was thinking vertical columns, not living objects. And the representation I have in a column. What could someone tell me that would let me change my hypothesis, make me more accurate? No, I couldn't figure out the answer to that question. I mean, I could say, yeah, somebody can tell me what the object is, but that's the whole problem, right? So, but no one can tell me where I am on the object. How could they? They could tell me where I might know where I am in space, and I could go thoroughly show other people one at a time, knowing where they are in space. Maybe someone could calculate a centroid or something like that, but I'm just confused by this. Maybe I didn't. Can we? What's the answer to that question? What could a cortical column be told to have it that would help it infer it rapidly?
Yeah, I guess what we basically do in Monty right now is we tell it where it is on the object. So like in the object's reference frame, what location.
How do you know the object's reference frame if you don't know what the object is?
Yeah, so there's one assumption that I don't know if it's reasonable, which is that the object was learned by all of the columns at the same time in one specific location. So they all have learned the object in the same orientation.
I mean, specific egocentric location, like
yeah, like the mark was on the table, and all of your columns learn the mark at the same time while it is in that orientation. So that
is that a reasonable assumption?
I thought it was kind of at the time, but I don't know. Maybe it's.
I mean, it feels like, yeah, we could accommodate it. Like right now, it's like a strict requirement, but if it, yeah, like we talked about ways that you could kind of accommodate in like an unsupervised way where, yeah, as long as that generally holds true, and you see the objects in many different instances, like in the future, you might be learning more about the mug in a different position. But the point is kind of like, it's not like some of the columns are getting like one version of the mug in one location in space, and other columns are getting this version of the mug in this location in space. Like the mug is basically presented to all of them as like a single object.
But yes, but over time it could be. I mean, any instance it would be one place, but in other places it would be.
And that's. I think that would be fine. I think that could be accommodated.
I guess I'm not.
I think it's only an issue if like you almost have like a VR headset that's like projecting two different images to each eye or something.
It's mostly an issue if it's like you learn it by looking at it but not by touching it, and then you try to infer it with touch in a different orientation. But I think that's maybe not something we need to expect to be able to do.
Also maybe I'm confused by this because when I think of reference frames, I'm always thinking of grid cells and how they work, and there's no shared reference frames.
It's not a reference. They all have their own reference frame. It's just they don't even have to. They're like different spaces. The main thing is that as they're learned, they need to be aligned in the orientation, so that if we then apply a displacement to both of the reference frames, it moves you through them in the same way.
I think I totally misunderstood this. So I apologize for that. I was trying to imagine how this stuff would occur in the brain, and was not even. I guess I wasn't really cognizant of how Monty was doing it today. So I'm not sure how much my analysis would be very valuable. I'm still struggling with it because I reach some sort of conclusions thinking about the neuroscience, how difficult this would be to do. But not knowing how you guys did it, using non-neurons, I should probably just get myself educated on that more and see if I can. I thought it was a fundamental problem as I couldn't resolve. I felt like I should be able to resolve it, but I couldn't get it resolved. How even if I had egocentric representations of where columns are, how I would be able to how they would help each other. How could a
You could,
column be told where it is in some location space, based on all these, the 100 other columns, when nobody knows what the object is?
yeah, because for what it's worth, I would say that, yeah, that part does work now, that like, even if you just get one observation and so it's inherently ambiguous, it's just a surface normal and some curvature at one point, that could be anything on pretty much any object. When it's combined with all the other observations, through voting, it can disambiguate the object.
Maybe I should read the K paper more carefully again. I just don't see, you can say that, but I couldn't see how it gets resolved. It's like,
Yeah, I made some write-ups and visualizations on this back some years ago when I implemented that. I can try and dig them up again and send them in the research channel.
yeah, maybe. This is a common problem I have, is where I think about a problem one way and I reach some conclusions from it, think about it the other way, that way, and other people think about it a different way. And then but my conclusions seem very solid to me. And, in my language, in my thinking. And yet, when people describe in other languages, they say, oh, no, it's not a problem or something like that. And I'm like, well, I still feel like it is. Like I have to somehow see where the failure of my logic was. Yeah.
So did you kind of come up with an alternative?
Well, I came up with,
if you want to discuss it?
Well, I thought it was worth maybe discussing. And maybe this is just some of my observations. I'll go back to sharing my screen. I thought there was, here's how I thought about the problem. I thought there was two classes of solutions to this. One class of solution I call the fully independent assumption. This assumes that center patches can have arbitrary poses relative to each other. There's no restrictions on that. And therefore it requires a central method for columns to communicate the relative poses of their center patches. It requires you have a central place where everybody's going to, and then that's communicated back out to all the columns. This is what I think you've implemented, and this is what my walking assumption was. And I had difficulty getting it to work. So I might just be missing something. Probably. But there's an alternate one, which is I call it the partially independent assumption, which is that center patches rely on the relative position on the retina or on the skin. And this could use local communication between the adjacent columns, that it wouldn't be a centralized sort of communication proposition. This is not where I started, but it kind of, and I didn't reach a conclusion, but this popped in and raised in relevance. Maybe just talk about a little bit, these two classes a bit, because I'll explain some of my thinking behind it. So on the fully independent assumption, this is attractive because it's a universal solution, right? It says, I can have any kind of center patches and any orientation with each other, and no matter what it is, it's going to work. So I immediately, when I started thinking about, common algorithms and inference is where I went. I said, well, what is the evidence for this? That there's a central repository. And so immediately I knew that when I talked to other neuroscientists about this, they would point out, well, the columns aren't in random. They're all arranged right in topological order on the retina. So they have these fixed relationships on the retina, which is consistent with the partially independent assumption. And then I said, well, let's not talk about, this is my own thinking now in the past. I said, well, let's not talk about vision. Let's move it over to somatosensory. Because there, it's clear that sometimes at least, that the skin, the sensors on your skin are not dependent on each other. And then I realized that that's not even true of like the skin on one hand. So if you notice, when I usually talk about this problem, I usually talk about two fingers on the two hands. Because I can imagine moving those two fingers in the tips of those two fingers in, one sensor patch on one finger, one sensor patch on the other finger. At least those seem to be independent, movable. So I said, this is why I described the problem with fingertips on both hands. And even the fingertips on the hands are not completely independent. Like I cannot move my fingers independently. So to prove that there had to be a fully independent solution, meaning a solution that required that they could work at any set of poses of sensor patches, I had to come up with an example that didn't require some relative positions. That it didn't have relative positions, and the retina didn't fit that requirement, and most of the skin didn't fit that requirement either. So you follow me so far on this?
Yeah.
Okay. I can't see you, so might as well just say yes.
Yeah.
But I never felt totally comfortable with that either. Ignore this next paragraph for the moment. Don't read this. Here's why. Because when I actually tried to do sort of flash inference with my fingertips, it's kind of hard to do, but it's sort of an extension of the Olympics you guys did. Try to like touch something with just the tip of your fingers. Don't get multiple sensor patches on your finger. Just one little tip. It's very hard to do. I couldn't convince myself I could actually do it. But I do notice when if I grab a mug with my hands and my skin wraps around the mug, it's very easy, right? My fingers will wrap around and the palm will be there. And in this case, I might be using the local connections between the columns. So I don't think I completely could have an unassailable example that shows that we actually do a fully independent solution. Even though that's what I wanted to do. That's what I started out assuming. Then I said, well, what is the evidence for the partially independent assumption? This is again, this is the idea that the local connection between columns are helping here. The columns know that they're adjacent to each other. I already mentioned this first one. Touch inference works best when I wrap my fingers and hands around the object. Contact with one continuous surface of my skin works much better than fingertip. But after that, I have mostly negative evidence. And I mentioned this already. We do not have an unambiguous example of flash inference or all the sensor patches move independently. I don't think I haven't proven that yet. So I haven't. It still might be possible. The fully independent solution is an n-squared problem, and you told me you solved this. It's just still not clear to me how it works when you have this n columns trying to help each other. And
That seems like a separate issue. Like, isn't it n squared with normal voting, even if it's just on object ID as well? It's just who votes.
But the voting mechanism we have works for that because it's tied to the next thing here. Voting, if columns are inferring the same thing, you can vote on it, right? So you can vote on object ID, even though in Monty there's a sort of a shared, I think, dictionary of object IDs, and in the neuroscience there isn't. Each column defines its own SDR for an object, but you can do this associative memory pairing, and it works for n number of problems. And we've shown that it works. It doesn't. It's n squared, but it's not. You have to go through it thoroughly. It just all resolves instantaneously, right? So it's not like n squared. It's n squared, but it's not in the sense that the voting mechanism is just a settling.
Yeah, maybe like one way of describing it is that like the computation between any given two columns is a bit more kind of bespoke. Or, yeah.
I mean,
did it make sense, Vivian? What I was trying to describe earlier about like if we just had like a general location for the objects, like that could, I think, be common to all the columns. Again, if they've kind of learned in the object in similar locations in the past and stuff, and then that feels closer to voting as it's currently formulated, where, like, again, they're just like voting on one thing. It's not like each And it's
Well,
kind of like before the column projects, like let's say one column is here, and this is its hypothesis. So before it projects the location of the object, it works out, okay, I'm here. I think this is where I'm on the object. So I'm going to project the center of the phone to everyone else. And then another column is here. And it's like, okay, I'm going to calculate what the location is of the center of the object and project that to everyone. So in that sense, it's more a bit like a common ID. It's kind of like a common location. I think functionally it would be the same as probably as what we do at the moment, but it would just be like a different way of calculating it.
I wasn't able to get your screen up in front of me to watch to see what.
Oh, sorry. Let me try that again. So one column thinks it's like here on the object. That's its hypothesis. But it's right now in Monty, we communicate that. And then if it's voting with a column up here, it kind of communicates that and calculates a bespoke displacement for between these two columns. I'm just saying instead of that, this column, it believes it's here. So it works out it's where the center of the object is, some kind of arbitrary agreed upon location. So within the column, it kind of figures out, okay, this is the center of the object. That's what I'm going to send to everyone else. And then this other column, it also says, okay, yeah, the center of the object is here. I'm going to send that to everyone else.
Yeah.
And so in that sense, they're kind of speaking a more common language.
Right. I guess that makes sense. Although we don't have a variable like that in our learning module, or at least in the cortical column. I mean, that would be each cortical column would have to have a hypothesis about the center.
Yeah. So I guess what I was thinking, I was trying to get earlier is it might be similar to the location of the object that you would want to send up the hierarchy. Because let's say also you're representing where the phone is in the room or something like that, or where the phone is, on the table. You want some sort of location representation for that. So maybe over time, columns kind of generally agree, like, okay, if we're going to talk about the location of this object, we're talking about here. And that might be center of mass. It might be something else.
Well, that's interesting. It's interesting because we after years of struggling, we abandoned that idea because it didn't work for compositionality and other things. And so I've gone completely the opposite direction. I was saying, there is no center to an object. There's just points in an object, and there's points that are aligned with other points in other objects. And so that'd be a big ask for me to abandon that and go back to the old way of thinking about it again, because it just didn't work. I felt like such a relief when we came up with a composition idea, the column by column. I mean, it could be. I mean, I guess you could be voting on some sort of center of mass. I don't know. I'd have to think then we'd have to have some sort of some cells in the cortical column that are doing that. But I don't even know I don't know. I have no idea how to begin thinking about that.
Yeah, I guess the only thought is it feels like it would be a little bit similar to the L5 projection in that before voting, you kind of want to convert it into like an egocentric representation. Because ultimately that's the space that the voting's happening in.
Right. So we can imagine maybe a column has something, it can change into an egocentric location.
But I agree with you. I also feel uncomfortable with the idea of like a single location for each object, unless maybe it's like kind of a fuzzy thing. So it's, I don't know. But then of course, the fuzzier you make it in space, then the less refined the voting's going to be.
Yeah. It's funny. The paragraph I had earlier, I said, don't read it yet, which was the idea that if I just hold my hand out in space in front of me, I'm not touching anything. I have a sense of the volume they occupy. It's a pretty crude sense in the sense that it's not like a detailed shape or anything like that, but it's like, I kind of know where my hands are, or which one's on the left or which one's on the right, how far apart they are. If I were moving my hands together and all of a sudden they touch something, I have a very good sense for the size of that object. So that's an observation that's in support of the independent hypothesis that says, there is knowledge somewhere in the brain as to the volume that your sensors occupy right at the moment. I assumed that it wasn't in the allocentric columns that we've been modeling so far, that it was, some sort of egocentric thing. But I couldn't figure out how to make that work. I said, well, that's evidence. It's there. I clearly know that. I know when I touch something, I have a sense for the volume of it and where its boundaries, at least some of the boundaries are. But then I couldn't figure out how to get that back into a visual, I guess your idea of if I had like a central point, we could all be voting on that central point, then yes, then I could bring that back into a column. That's right. All these things just made me a bit uncomfortable and confused. So maybe I'll just not, again, I didn't reach any conclusion. And maybe my analysis is not very useful yet. I don't know. Let me just finish going through it if you don't mind. You can decide whether you find it useful or not. This paragraph here really got me for a while. And you just partially answered it. What information could a column receive that would allow it to infer without movement? I don't think it can be told its location because its location's in a code that it's unshareable, that no one else knows anything about its codes of location. So, but as you point out, it could be given something in a common egocentric value and turns somehow into a local allocentric value. I'm not clear how that would work. But this, sorry, I said it can be told the correct object ID. That's what we do in voting. But that just pushes the problem elsewhere. And somehow, it seems like I need to somehow use a columns model. But so I think you gave a partial answer to this question. I said, I'm open to suggestions, and you at least propose one.
Yeah. Although one interesting thought just right now is like, maybe part of the issue as well is like, standard voting kind of makes sense in neurons because even though two columns don't know the same object ID, they vote on, we've formed an associative connection between, these two SDRs. And so in another instance, we see that object, this one can say, oh, I think you should predict this SDR, even though I have no idea, but even though that SDR doesn't look like anything like my SDR.
Right.
But that seems harder to do for locations, even if it's egocentric, because you can't just make like an associative connection. Like, let's say it was in location, I don't know, 1.5, 0.1, 2.
Yeah.
And then, it was the same in the other one. They each have unique location codes. Even if you associate those, now
Right.
they're in different locations. So how did they share that?
Right. Voting requires that you learned these associations from stable patterns. That's
Yeah.
right, Jay.
I think maybe a concept that this discussion reminded me of this page in our documentation. I'm just going to share the screen real quick.
Can we stop sharing?
Yeah, about the difference between sensors and agents, where an agent can have multiple sensors, and right now we're showing like an eye agent and a finger agent. But if there's a human agent, then we will have sensors on both eyes and touch, but one agent. And I feel like even if the sensors,
I'm lost, Jay. What's the difference between an agent and a sensor? Again,
so sensors, in my
is an
head,
agent something that moves? Maybe an agent.
Yeah, and an agent is the thing that's moving, and then all the sensors attached to an agent are moving together.
Okay, that makes sense.
Yeah. So in that description, we would technically describe a human as a hierarchy of agents.
right?
And so the lowest level agent is where the sensors are fixed relative to each other, kind of like the partial correlation or whatever that you were talking about, Jeff.
Right.
Yeah. So even if these sensors are like, if the sensors on the eye and sensors on the finger move independently, I feel like eventually the highest level agent, in this case human, like would be able to kind of consolidate the information about where the sensors are relative to each other to like calculate, to do the vote. Like I feel like the human agent is like the central location where all this information.
This is confusing because if the agent is just literally the thing that moves a bunch of sensors, then I wouldn't, in that definition, I don't think the human agent doesn't exist. In my mind, oh yeah, the fingertip that moves is one piece, and the retina that moves is one piece. But as soon as you start having fingers and eyes, then you have multiple agents.
Yeah.
So I wouldn't think like there's a human agent. There's just multiple agents that are moving around. In this definition, I mean, in other definitions, you can say,
Right.
yeah,
Right.
humans
But
made
I
it.
mean, I
So
think,
I don't know.
yeah. So I mean, there might. So I guess I was thinking. Well, one is that we have one agent where the sensors are at very two different locations, like groups of sensors at two different locations. Like one human agent that has both this sensors and those sensors. I think what Noah was talking about with the hierarchy is that there's two agents. There's an eyeball agent and a fingertip agent, and maybe like a orchestrating agent, like human, that controls both of those. So like eventually, I guess in my mind, I was thinking about it as like there's eventually like one, at least one agent that knows like everybody,
All right.
all
Well,
the
that's
sensor positions.
so I'm not sure where the point you were going to get with this, but it does fly against the idea that the agent is just the thing that's moving the sensors. Or a fixed set of sensors. So how does this relate to it? Now I'm really confused. So how does this relate to what we were just talking about?
Maybe I just make things more confusing. No, it's that going back to the post fully independent or partially, like I think if there's one agent that eventually knows all the sensor locations, then that means that we can always calculate the relative positions of
All
the
right.
sensors.
Well, let's
What does that mean, kind of
agent.
from a column point of view? That like an agent, like I think rather than talking about agents, it's useful to think about columns, because I feel like an agent is like an abstraction almost that we've come up with mentally, but at the end of the day, it's columns communicating with columns everywhere. And maybe there's like a mapping sometimes between columns and agents, but I feel like if it's possible to kind of frame it in that way, I feel like it'll be clear.
I guess, yeah. Well, I guess it's probably most analogous higher order column. Like, yeah.
So you're saying a higher order column would know where the finger is relative to the eye, and then it would project down to the finger and the eye column, telling them how their relative location is for them to vote with each other?
I think it could help for sure. They're not a very well developed.
Right. Well, those are
Right.
kind of right. And those are kind of ideas like, I thought of similar ideas like, oh, is there some sort of hierarchy composition going on here that, sort of like we described, Jose, but it's all too fuzzy for me.
Yeah, I agree.
Would the idea of a phantom limb or like all those illusions help here? Because they seems to support that perhaps our egocentric coordinates are learned in the learning modules and not like innate in the neural wiring. Because, where people put a fake arm next to yours and then they slam it with a hammer and you just react to it, you like very rapidly learned that your arm is now over there. And that seems to be evidence against like hardwiring of egocentric locations and more about learning modules having a model of egocentric locations.
Well, that only works like there's two things you're talking about there. One is like this idea that you can fool yourself to thinking that the hand is your hand when it's a rubber hand, but your hand has to be pretty close to it. It can't be off in the other direction. It has to be like right next to it, and you just can't see one. And so that's sort of like that would still argue that that's sort of like it reminds you of grid cells, where like you think you're in one location and then you've distorted the room and it's now distorting your location space or something like that. I'm not sure if that relates there. I think obviously it's a separate. It's clear the brain knows where your limbs are, right? I mean, it up to some accuracy. I guess maybe a lot of those things have to, not the phantom limb, but the one where you feel you're fooled into thinking the rubber hand is yours. That's sort of like within the accuracy range. It's sort of like you can distort it because it's just slightly off, and you can fool it by sensory input. But I don't think you can fool it by if your hand's behind your back and you see this rubber hand in front of you. It's not gonna happen. They have to really that's a trickier problem. You know, just one more little observation I had, which struck me once, I thought may be useful, is often I was imagining my finger going along an object, and then occasionally it would, like if I was going along the rim of this cup, and then as I'm going along, I hit the handle, right? And maybe I didn't know I was going to hit the handle. I'm just going around the rim and I hit the handle. That's basically an activation on the side of my finger. So the tip of my finger is following the rim, and then the side of my finger hits the handle piece. And it feels very local. It feels like that. I mean, I guess this hand waving argument, but it felt like very local, not like my brain feels like the side of my finger and the front of my finger are two separate things and has to figure out where they are in the world. It's just, no, it sounds like, yeah, I know it's right there. You're right next to this one. So it's like this set of sensor patches on my digit of my finger seem to sort of work together. They don't seem to be independent. They seem to be, they know exactly where they are relative to each other. And those things don't move on the digit of my finger. Yeah, I can move the digit, but I can't. Anyway, it's all hand waving arguments. It's not very good.
I
Yeah,
guess
that one feels like, I was going to say, sorry, with that example, like that feels like hierarchy could help with that, at least. That, like, I don't know, you have a column that's just this patch of skin, and another column this patch of skin, but you also have a column that's kind of the sleeve of this finger or something like that.
Maybe, but it doesn't feel that way. It feels more like I have one on the side and one on the front. It feels to me like I just had a way of describing it, just stepped out of my head. It's almost like this finger of all these things around, these sensor patches around it, and there's many sensor patches on your fingertip. They're working as a unit somehow. They are a unit, and they recognize certain patterns amongst themselves. That is, that they know when there's a feeling here and a feeling here, or like this is the cup with the chip in it. When I get to the gap where the chip is, my fingertip feels both edges of the chip. It feels like that's something my fingertip knows. It's not like a bunch of sensor patches know, and they have to communicate through some central communication mechanism. It feels like that's like the fingertip knows. Anyway, it's not a very strong argument, but it's possible that both mechanisms are at play. It's possible that there's a centralized mechanism, and there's also local stuff going on too.
Yeah, that could be kind of approximate local stuff happening without external input, like kind of localized lateral bowing that's pretty much within retinotopically neighboring areas.
Right. Or fingertip area.
Yeah, but then if you have like a more long range kind of lateral connection, like from one finger to the other, or from the finger to the eye, visual cortex to auditory cortex, that might have to be routed through something that does a reference frame transform or use hierarchy to take into account more of a model of where things are relative to each other on the body.
So then I asked myself, in vision, what if I had a similar mechanism like this going on in vision? So local patches of my retina, which are many, many sensory patches, are like similar to my fingertip, right? What if they know certain things that they vote locally, and they're all able to do this? Well, how could you solve the flash inference problem under that assumption? Would there be enough information that I could extract between local interactions so that would be sufficient to lead to the global solution? And I couldn't convince myself one way or the other on that one, but it still seems possible. It's in the sense, like, as we showed in general with when we first did the first paper on Thousand Brains, we showed how just with few movements, you could generally settle down on the right solution. And so that didn't have any centralized voting. And of course, with a few movements, you're no longer doing bag of features. You're narrowing down very quickly. And so then I felt like, well, maybe there's these local voting on my skin and local voting on the retina would be sufficient to just essentially solve the problem. And I couldn't convince myself one way or the other about it. That's
wouldn't it be biologically plausible, if, like you said, to have both? Because like one way I'm asking for the biologically plausible way of local patches is in development, everything is connected, and the local patches, those are predictive of each other, so those connections would stay alive, versus the things that don't predict each other would start getting pruned in development. So you'll
Right.
get like these patches of where the local partial things work together versus the things that are not correlated just are not wired
So
anymore.
so in the brain. Imagine you're in the brain now, or on the cortical sheet, right? And so you're in some somatosensory area. That somatosensory area ends, and the next, and then another region, which might be a different modality, starts, right? So you might have a vision region touching up against the language region or something like that. Well, presumably then the connections that are local connections would not be correlated, and they'd be lost, just like you're saying. And we've talked about this before, but one hypothesis about synesthesia is that those connections remain, and they shouldn't be there, and therefore you're making these associations across modalities which are incorrect, because they should have been forgotten. We're treating adjacent columns. Here's a color column, here's a sound column, and they should have no connections between them. And yet, if there is one, then your sound has color. So
It's
Yeah, I kind of like this idea of maybe it's a combination of both, and it's just associative learning of what remains correlated and what doesn't.
right.
Sure.
So,
but I guess doesn't it still raise the question of how space is taken into account? I feel
Yeah,
like
it
you still
doesn't-
risk a bag of features in even
Well,
if it's local.
maybe I don't think so. But one thing that we could do is there's a clear evidence in my mind, the idea that I have a sense of the space my hands are occupying, even if they're not touching anything. That to me was like, wow, there is a central idea of location of an object somewhere. Can't deny that. And then this idea of my fingertips sort of recognizing weird little nuances on a cup and so on, also pretty strong for me. And so I could argue, well, there's probably both of these things were going on somehow. We could decide to pursue them or not pursue them if we want. I mean, I didn't work on what would an actual mechanism for local voting be. But I could think about that. But I think it's possible that you have multiple mechanisms going on, just like the vid said.
Yeah,
What we want
we
to
don't
do about this, I don't know.
yeah, we don't understand either of the two, but
Right.
they're
But
both-
it sounds like you have a solution in mind already. So why are we doing this?
Yeah, I mean, the main motivation, I guess, for us to question how we're doing it currently in Monty is because we were thinking about sending movements as input instead of locations in egocentric shared space. And if we only send movements, then we don't know where sensors are relative to each other anymore, because we don't have the shared coordinate system. And that was kind of where the question came from.
Is that also an issue for the outputs? Just thinking about it now, because at the moment when we send like a command, again we need to convert from the kind of object-centric space to egocentric space, and that again kind of requires that column knows sort of where that object is. So even if I guess that could be a movement.
I mean, yeah, that would be a movement too then, so it wouldn't matter in this case.
Yeah.
But yeah, also just as a reminder, we are over an hour in, so I don't know if you want to keep digging deeper on this topic or kind of...
All right, let me see if there's anything else I want to only one other last observation I would say. I wonder whether there's any evidence that even in visual flash inference, that even though we present it and it goes away quickly, that there's not an existing trace that somehow gets processed later. Like you are able to attend to different parts of the flashed image, even though the flashed image is no longer there. So I don't know if this is,
Yeah, I think they try and, I mean, who knows if it works. I think because often in psychological experiments, this idea of flash inference of like a complex scene, I think it's called the gist. Like, can you get the gist kind of and yeah, so things like a street scene and whatever. And often they follow it with masking. So they'll show it for like 70 milliseconds or something, and then they'll show some white noise. And then the
Right.
idea is that the white noise should prevent you from doing recurrent processing, but no one knows for sure if it does.
so that experiment was inconclusive.
Well, as in, like, how do we know that that mask is actually having that effect? But
Oh,
people
I see.
can still recognize it, I think, with masking. But I think it is a bit harder, which I guess supports that it is doing something. The mask.
You know, what they
But-
did was kind of just flash inference experiments with showing things in unusual orientations.
Yeah. No, I can't remember. But
Because
Yeah,
even if we assume that they know their relative locations and that is kind of a fixed relative arrangement, if we want to recognize stuff in any orientation using flash inference, it would still require always doing reference frame transformations between the different sensor set or columns that vote with each other. But if we would assume that kind of canonical orientations work very well, but non-canonical ones don't work well, then that could be just a more hardwired associative connections.
yeah, and I think that does fit with at least some evidence that people are, if you give them less time, they're worse at atypical orientations.
Right. I think if I did that little flash inference exercise in the beginning, and those images were upside down or inverted, I bet you'd have a lot of problems. If I could do that experiment. Anyway, I hope this wasn't a waste of time.
I don't know.
No, definitely not.
Well, I don't know. I feel like I failed. So.
No, I think it was interesting.
I still, don't understand Monty well enough. It's my failure. If Monty gets more and more capable, I'm going to be like behind.
I feel like, yeah,
Sorry.
maybe just briefly, one example that Scott has mentioned before that's maybe a problem to think about more after this, which I thought was an interesting one, is sort of the inverse of the moving the finger over the mug to recognize it, which is, someone drawing on your hand or your back or whatever, and then you recognizing that object. Because it's kind of interesting. It's a little like flash inference, but it requires kind of integration over time. Because it's not like something's pressed into the palm of your hand and it's seeing everything at once. It's it's tracing it out. So yeah, I don't think we should discuss it now, but I feel like it's just one to maybe think about.